you remember last Friday, it seems like a long time ago, but we didn't know about shortcuts. So to prove that triangles are congruent, we first had to prove that every single corresponding side and every single corresponding angle was congruent. So if all that was true, if all the sides and angles are congruent, then the triangles are congruent. Well, the converse is also true. If the triangles are congruent, then all the corresponding sides and angles are congruent. Okay? So if, for instance, I needed to prove that angle E was congruent to angle R, are they marked congruent? No. Right now, at the beginning of that proof, I had no idea if angle E was congruent to angle R. But I proved that the triangle that it was part of was congruent to the triangle that that angle was a part of. And so I know that for these triangles to be congruent, all their corresponding sides and angles also have to be congruent. So are angle E and angle R corresponding? Yeah? Yeah? And so I can say, well, because they're corresponding, and I already know the triangles are congruent, then I can say that those two angles are congruent. So it's a way of proving that pieces of the triangle that we're not given are congruent. Okay? It's like I said, converse of what we did earlier this week. So we have a shortcut for that called cpctc. It stands for corresponding parts of congruent triangles are congruent. cpctc. Corresponding parts of congruent triangles are congruent. Okay? So if you prove two triangles are congruent, then you can say all their corresponding sides and angles are congruent. Okay? So what that means is if I can prove that two triangles are congruent, then I'm allowed to say any other corresponding side or angle is also congruent. So can I prove these two are congruent? Yeah? I need my three things. What are my three things? What are the three things that I can say are congruent here? Well, but give me the things I can use. I can say angle C is congruent to angle F. B is congruent to E. Right, and CA is congruent to FD. Okay, so by angle, angle, side, what triangles are congruent? Right, ACB is congruent to triangle DFE. Okay, so I've proven these two triangles are congruent. So now, if I'm asked, is angle A congruent to angle D? If that's what I'm asked to prove, first question I ask myself is it corresponding? Are angle A and D corresponding? Yeah, because they're in, how do you know? Well, but how do I know they're corresponding? Where do I go to look to check for corresponding? Remember, corresponding angles and sides have to be in the same order in the two triangles. So A and D are corresponding because A is first and D is first. C and F are corresponding, B and E are corresponding, side AC corresponds to DF, right? That's where I go to find, just make sure they're corresponding. So once I have all this proven, then I'm allowed to say angle A is congruent to angle D by, oh, this was angle, angle, side, sorry, by cpctc, because it's a corresponding part of congruent triangles, so it's congruent. Okay, cpctc. All right, I think The best way I've ever seen to look at this is with um, a flowchart proof, because it lays it out exactly. It says these three, you have to have three things to prove the triangle's congruent, and once you prove the triangle's congruent, then you can say part of it's congruent. So it like really outlines it exactly the way it flows. Okay. So what three things go in here? What are the givens? Right. AB is congruent to DC, which is given, and angle. Okay. And then I run out of givens, so can we come up with one other thing? Do we know angle A is congruent to angle B? Hope not, because that's what we're trying to prove, so it would be a waste of time. I'm sorry? That would go in the middle bubble. Well, yeah, no, the A and D, yeah, will go in the last bubble. You're right. You're right. So we've got A is congruent to C. We've got side AB is congruent to side DC. So think about the triangles. This angle joins these two sides, so the triangle must be here. And this angle joins those two sides, so that triangle is there. Do we know any other sides or angles that are congruent so I can get my third thing? Yeah, exactly. Always be on the lookout for those reflexives because they're helpful. So BC, which is the base of the green triangle, is congruent to BC, which is the base of the blue triangle. And that's reflexive. Okay? So I've got this. So why would my triangle be congruent? Side, angle, side. Good. So I can say triangle A, B, D, A, B, C. Guys, you really don't need to pick up till the bell rings. It's congruent to triangle. Wow, the other classes got to, we're going to have to do a lot. All right.